Hi everyone, this is Yashasvi. I am a third year college student and I've recently cracked Google internship. I did a step internship in this summer, which is 2025, but I got a PPI and I'll be returning again in 2026 as a SWE intern at Google.
Hello guys, Jane Street offers a CTC of 4 crores in INR for their quant software engineering roles for freshers in India. Okay. Like we can see that, recently Jane Street is offering about 4 crore to top IIT graduates to develop algos for HFT trading despite its trouble. Right? You can see the news here also. So Jane Street does offer a package of 4 crores. And this was the recently asked Tree DSA question in Jane Street. Okay. If you click on the link, you will get to see the problem. So it is not a direct, nothing is directly written in this problem. A story has been made up. We have to decipher the story and try to understand and try to solve it. Okay. So that's how we are going to do it. Obviously, you will not find this question as a lead code standard problem, nor will you find it in standard DSA sheets or blind 75. This is a totally hard unseen DSA problem, and Jane Street only want to hire those people for such high packages, the kind of people who can use their brain entirely and can reach the solution to hard and new engineering coding and algorithmic problems. Okay, so how do we approach a problem like this? Because guys, you can also crack such offers. All you need to do is just push yourself a little to think a little more. So I will make this question easy for you. Basically, they are saying that a tree is given to you. Some nodes in the tree are having value as 0, some nodes in the tree are having the value as 1. So first, let me show you what's actually happening. So like a tree is given to you. Tree is nothing but a graph with n nodes and n minus 1 edges, right? So this thing is given to us. Okay. So like a tree like this is given to us. Okay. Like each node has a value 1 or 0. Each node has a value 1 or 0. Okay. So let's do it like this. Okay. So let's call this as node number 1, 2, 3, 4, 5, 6. So they are saying that there are two people who are going to travel these trees. Okay, person A and person B. So person A will start traveling from node number 1 and person B will start traveling from node number n. So n nodes are given. One person is standing at node number 1, another person is standing at node number n. Both of them have to do some traversals and they have to reach back their original position. Node number 1, if you start traveling, in the end you have to reach node number 1 again. Node number n, you start traveling, in the end you have to reach node number n again. So, what is the purpose of traveling? You have to travel in such a way such that you cover all the nodes whose values are 1. You should be able to cover all the nodes whose value is 1. So, we start our traversal from node number 1 like this. Okay, this is the answer. You go from node 1 to node 3 and again node 3 to node 1. So, you go from 1 to 3 like this and then from 3 to 1 like this. Okay. So, it took 2 moves. And from node 6 you will go to node 5 and then from 5 to 6 again you will return. So from node 6 you will go to 5 and again you return to 6. So 2 moves here. Total 2 plus 2. In 4 moves you are able to solve this coding question. In 4 moves you are able to start your traversal from node 1 and go back to node 1. Start your traversal from node 6 and go back to node 6. Okay, that's what you're able to do, right? This much is very clear. Okay, but why is this traversal useful? We have to tell the minimum number of moves. Here, the 4 is the minimum number of moves required to start the traversal from 1 and go back to 1 and start the traversal from n and go back to n, such that in this traversal, can you see all the nodes whose values were 1 got covered? This node was having value 1, it got covered in this traversal, and this node with value 1 also got covered. The node which had 0 values, they may or may not be covered. That's okay. So we do understand the problem. So indirectly, if you decipher the question, the traversal is starting from those two nodes, node number 1, node number n. Travel in any way you want. But in the end, the person who started traveling at node number 1 should again reach back to node number 1. And the person who started traveling at node number n should again reach back to node number n. And once the traversal is completed, you can visit the same edge multiple times. But you can see by common sense that you maximum at maximum you only need to visit a particular edge 2 times. That can make your observations easy. So the things are pretty simple, right? The only thing is that we don't know how the traversals should be, so that all the nodes with value 1 get covered in our traversal and the number of moves are minimum. So before we go ahead, guys, you need the knowledge of coding and tree and DSA. In case you guys don't know, don't worry, the code links are also added. You just do this prerequisite course of mine. Let me give you the link to it. Yeah. So like I will teach you the insights, intuition, logic. See, I have to teach it in a very small duration. If I want, I can explain everything for 2 to 3 hours in too much depth, but YouTube does not, algorithm does not allow me to do that. So I will have to rush it a little bit. But in the comments, you can ask me for deeper insights if you want. For now, like in this small amount of time, also I'll try to explain in the best way possible. You need to complete this prerequisite course, specifically the tree part, because these days companies are asking hard unseen DSA problems of general trees. So I want you to complete all the tree questions from 1 to 5. If you have done this, then you will understand whatever I'm teaching in this video. So please do my free course. It's available to everyone. This is the link. Okay. Do the tree part. I assume that you have done it. Let's go ahead. Without doing that free course, you will not understand if you don't know trees and DSA nicely. So guys, I have taught a trick to my students in my 851-hour structured course, in my one-to-one mentoring, day life training, and where we give job reference support. I have taught them to always try to solve for a very simple tree. Try to solve the things for a very simple tree first. Always try to solve the things for a very simple tree first. So let's try to see what happens with a linear tree. The problem is difficult because we can go into many wrong edge cases. So if the tree is like this, and this is node n, okay? All the nodes are having values as 0. This node is 1, and this node, like this node value is 1, okay? Okay. So you know that you will start your traversal from here, right? So one basic observation, you will start your traversal from node 1 here and from here and here, right? So one basic things come in your mind is that you should start BFS from this and start BFS from here, right? So they will start traveling the nodes which are closest to them. Basically, all the nodes are having their value as 0. This is also 0, this is also 0, this is also 0. All nodes are having value 0. Only 2 nodes have their value 1, and we have to visit those nodes in minimum number of moves. So if you start, we have to start from node number 1. So I will try to find the shortest path. Just find the shortest path from this node to the closest one. You find it and then you go back. So what was the shortest path? It was length 1, and you will multiply this 1 by 2 because you have to go back. So it took 2 moves to do this one, right? And from this end, if you start the BFS, you quickly reach here. This path is of length 2. You go from here to here and then you come back. So 2 into 2, right? 2 multiplied by 2. So which gives you 4. So 4 here, 2 here. Total, it took 6 moves to solve this problem. So you can imagine it in your head that like this is the first intuition which should humanly come to you. This is node 1. This is node n. Let's say it's type of a linear tree, okay? There is this node with value 1 here and there is this node with value 1 here. So this node on the left hand side, it should be visited in this order from node 1 like this, here like this. So this node with value 1 gets visited because we have to travel in such a way with both these traversals, like both the traversals are happening, right? You can consider these traversals independently. You can consider first this traversal is happening, then this traversal is happening. You can consider like this also, that first you went from here to here, then this went from here to here, then this from here to here, then this from here to here, then this from here to here, here to here, then this from here to here. But you can observe one thing, that if you consider this full traversal first, then you consider this traversal, it does not matter, they are independent actually in the minimum number of moves whenever you're trying to consider minimum number of moves. So whichever node is having value 1, try to find the shortest distance from 1, travel it via node 1 only and then go back. Here also shortest distance node, travel it via node and then go back. Okay, you understand these things, I love you. This is a general answer, but this is not the final answer. Like never do this mistake, like this is node 1, this is node 1. Never do this mistake that from node number n you try to reach this node and then you come back, and from node 1 you try to reach this node vertically and then you come back. This is not good. Why? You guys can write in the Google, like I teach so much in my Google Meet that I have this urgency to say Google chat, but in the YouTube comments you can write why this is not good. Why? You are traveling from here to here, going back, you're traveling from here to here, going back. So can you see all the moves in this path got repeated, like clash is happening, intersection of these paths is happening. Intersection is wasting your moves. Intersection is wasting your moves actually. You cannot have intersections. So the first biggest observation is that whatever paths you will generate from node 1 and whatever paths you will generate from node n, they should not have any intersection. So from node 1 you will go like this till somewhere and then you will return back like this. From node n you will go somewhere like this and then you will return back like this. This is the first observation. If there is intersection happening, then you are wasting time because intersection is not needed. If intersection is happening, then some paths are getting visited 4 times. Some edges are getting visited 4 times. Only getting an edge repeated 2 times is easy. See guys, can you see? Even in a linear tree, the observation and things are getting so complex, right? And if you try to do it directly for a tree, you would never be able to solve this complicated thing. That's why I use my tricks for these hard unseen DSA OECP problems. How do we approach this 4 crore CTC problem? Let's think about it. So, okay, 1 to n. Okay, I can feel it. Okay. Even this approach is not correct. Many people will think that attach this to node 0 and start the BFS from here. Here, whichever are the closest nodes, from here I will always make them visit via node n, and closest nodes here I will make them visit by node 1. This is also wrong. Like, you need to check some edge cases. I will show you some edge cases which will blow your mind away. So let's say, let me think, let me think a little bit. Okay. See, if you do your normal rest, let's say the rest of the nodes are 0. So if you do your normal algorithm via BFS from both the nodes, you can trying to do multi-source BFS, you are going to fail. Why? Because from node 1 you will go like this, right? And from node n you will cover this node, right? Great job, nice job, love you. But now what? Now the things are getting very complicated, right? Things are getting complicated. See, the closest things you have done. Now this one should be given to which guy? The distance from here is also same. The distance from here is also same. So you can say, okay, let's go with the left one only. Okay. If you try to go it via left one, then you again have to return back, right? And for this, you have to return back like this. So how many edges were here? 2 edges were visited, and then you will multiply this by 2. Here, 1, 2, 3. 3 edges multiply by 2. So what is the answer? 3 into 2 plus 6, 4, 10. We think 10 is the answer, but 10 is not the correct answer. Let me show you a better way. There was no, like, you can, if you want, you can abandon traveling from node number n. So what we will do is, we will start at n and we will do nothing. We will stay at n only. The best path is from 1 you go like this, go like this. Okay, 3 edges have been traveled. Just go one step ahead and then go back. It is what? 4 edges, 4 into 2. All the ones got visited in just 8 moves. If you don't do anything with the node n. Wow, man, wow. So even though this node is at a shorter distance from node n, still we are picking up the bigger distance because the earlier nodes traveled are somehow contributing. They are decreasing their distance now currently if you do go from here to here, because this much was already traveled. Each edge is, whenever you travel an edge, it is just 2 times that edge contribution. You can see that we cannot just run BFS from both the sides. Even if you try to do some smart multi-source BFS, some students can do like, sir, when I reach here, I will again tell my BFS that this is starting from 0 length, so that the length can be adjusted and BFS go properly. No. BFS is not an algorithm. BFS only works when multiple sources or a single source from 0 propagates its value properly. If you keep on updating the lengths of the BFS in a wrong way at different locations, even by using priority queue, it's gonna screw up. When lengths come from here, some lengths will be small, some will be bigger. You will get confused. This is not a clean way of doing. So guys, the observation is pretty simple. All you gotta do is just do the brute force. Like in Jane Street, O of n square solution was enough. But we do have a O of n solution also. O of n solution I will discuss in the second part of this recording. And the second part will be, the recording will be attached in this video's description. But with n square also, the interviewer was pretty happy because n square solution is also very difficult. For this case, guys, what you can do is you can just brute force. How can you brute force? Pretty simple, bro. Pretty simple. You know that no matter what is the tree, node 1, like let's say the linear tree is like this, right? No matter what is the tree, what are the values 0 or 1, the best path will always look like this. It will start at 1 and it will, turn back from some prefix. Which one we don't know. It will start from n and it will turn back from some suffix. We don't know which one. But this will always pick up a prefix. This will always pick up a suffix. So guys, we can just try to break an edge. If you break this edge, it means that now this much part can only be traveled by node number 1. So if this much part can only be traveled by node number 1, what will be the answer for this? And this much part can only be traveled by node number n, what will be the answer for this? Add the answer. That is one possible answer. If you break the tree at this location, we will try breaking tree at all possible locations. So let me show it to you what I'm trying to say. Some people might not understand. So 1, 0. It's 1 like this. It's 1 like this. It's 0, 0, right? So this is your node 1 and this is your node n. So there are so many ways to solve this problem, right? So let's say I break the edge here. So break the edge means, like only this much part is allowed to be visited for person 1 and this much part here. Because the best answer will always have a left breakup and right breakup, right? This is the observation and visualization. So if you do it here, the edge is visited here are 0, and here how much you will have to visit? You will have to go till the farthest one. So you are forced to go till this one and then return back. So 1, 2, 3, 4, 5. 5 twos are 10. It took 10 edges. So if you break this edge and then you solve for these two linear trees separately, the answer is 10. Now let's try another iteration, another breakup structure. In the best answer, it could happen that we try to break this one, right? So this much part is allowed to be visited by a person and this much part, because final answer will always be like this only. It will be either of the structures. So I have to visit this and come back, right? So it gives 2, and here to visit this. I only have to visit it till this node is having value 0, right? Only visit till this one, the farthest one. Then you can go back. If there is no more one, why are you going there and wasting time? So it takes how many edges? 1, 2, 3 edges here. 3 into 2, 6. 2, 8. 8 is the answer if you do the breakup like that. So guys, you will try to calculate the answer by breaking each edge one time. So when you break this edge, the answer was 10. When you break this edge, the answer is 8. Like this, you will try to break each edge. And all different answers you got, you take minimum of them, the problem is solved. So we know how to solve the problem for linear tree in O of n square time. How in O of n square? In the first iteration, you break this edge, right? Like you break any random edge. Node n 0, right? Like 0 n, like n 0, right? You break any edge like this. So this is the part, this is the part. Now in both these linear parts, you have to find the last occurrence of one. It can take O of L1 time, whatever is the length of this part. And you have to travel from here and you have to find which is the last occurrence of one, because whichever is the last occurrence of one, you will have to travel till there and you will have to go back. There are many deep insights, intuition, logic I can tell you, but I'm only telling you the ones which are at most needed in this recording. So it takes O of n time after breaking a edge to solve the question, and you have to break n minus 1 edges. So n minus 1 edges you are trying to break, and each time you break a edge, you again have to do the traversal, right, of the whatever two linear trees you have got to get the, like from this direction what is the last one coming, and from this direction what is the last one coming, because whatever is the last one coming, like when you took this part, this was the last one coming, so you only have to travel this much part and go back, because we ultimately just have to cover the ones in our the traversals, right? But what if it is a normal tree? Then what will be the solution? Let's think about that. We will try to break it in two subtrees. Whenever you delete an edge in a proper tree, it breaks up in two subtrees, and solve those two subtrees independently for each edge. Solve those two subtrees independently for each edge, and that will be the O of n square solution. For O of n optimized, you guys can write your ideas, okay, in the Google, in the YouTube comments. Now let me show it to you how it happens for a tree, right? So Ram, like this is not a linear tree now, okay? So you know any types of edges might be going anywhere, right? Like this, so anything can be happening anywhere, right? So if you decide to, you will try to break each and every edge. Let's say you try to break this edge. This edge breaking means that from node number 1, you will always travel this much part, okay? And try to see what is the answer. From node number n, you will always try to travel this much tree and try to see what is the answer for this much tree. What is the best way to travel this subtree created such that all ones are covered and only one traversal is allowed from node n? When you are separating this, these problems are becoming independent, and this is leading to an easier problem, easier thing, okay? Now guys, imagining it for linear tree is very easy, but can you see if you directly try to do the tree question, you would never be able to reach this logic that whatever we are doing, we are visiting some edges and coming back, right? So these edges would be the closest to node number 1. So it will be an area around node number 1, and then this will be an area around node number n. So both those areas can be separated by breaking an edge, because these paths can never intersect. A path from node 1 can never go like this here and this goes like this here. Intersection never happens. Because the intersection never happens, let's say it visited like this, then up, see, no intersection happened. And let's say it visited like this and then back and then back. Because no intersection happened, it is allowed to break them into subtrees. Such a deep conceptual thing. My goodness, my goodness. It really deserves 4 crores actually. So once you break the problem into subtrees, how do you solve for a single subtree? So guys, if I tell you the solution for the single subtree, the problem is fully solved, right? So let's say only a single tree is given to you. Now how will you solve this question? Now it's a very simple, like you can do it while sleeping also. So this node is 0, this node is 1, this node is 1. Rest of all the nodes are 0, 0, 0, 0, 0. So what will you do? You will do a smart topological sort type algorithm. Topological sort type algorithm, also called as special tree pruning algorithm. Also called as special tree pruning algorithm. I really enjoy this problem. Like I love my life. So what you will do is that you know that you are forced to start from node number 1, right? So you just have to travel the nodes whose value is 1. So what is the best way? Best way is go from here to here, here to here, and then yes, the same back, the same path. This was the answer. So all you had to visit is this edge and this edge. Like when this voice was coming, I was feeling very different. Anyways, guys, with every ingoing and outgoing breath, you always have to take the name of God, Ram Ram, like this. This will make you reach moksha. Nothing is more important than this. So please focus on this, okay? I got that itchy feeling while doing this. Anyways, so 2 edges, so answer is 2 into 2, 4. But how to figure this out? Simple. Target all the leaves. Whichever leaves are having value as 0, we never have to visit them. Guys, this same algorithm you will not believe I taught 5 days ago in a Cisco online assessment problem. It is available. Like I will give you its link in the YouTube comments. That's why I'm telling you, please learn from our channel. It will really, really help you a lot. Remove all the leaves whose values are 0. Removed. 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 Because these leaves with 0, you never need to visit them. Now this is the new tree. This is your new tree. In this new tree, check which are the leaves which are having 0. Now this is the leaf. Remove it. Wow, wow, wow. This is now a new tree. Which is the leaf with the node 1 is never a leaf, okay? Which is the leaf with value 0? This is the leaf, but its value is 1, so not remove it. So remove this also. Guys, finally you have reached a tree where all the leaves are having value 1. This is the only single leaf value 1. So whatever tree remains which has all leaf values, guys, all leaf values are 1. How many nodes are there in this tree? There are only 3 nodes in that tree. So only 2 edges. All the nodes of these edges of this tree has to be traveled. So the solution roadmap is like this. Like, you know, deep mind tree, you will break it into 2 subtrees. Like you will destroy one edge and it will lead to subtree 1, subtree 2. To solve this, what you will do? You will do the tree pruning algorithm. The tree pruning algorithm will finally give you a tree which has all leaf values are 1. If all leaf values are 1, then you need to visit this entire tree. If there are G nodes in this tree, then it will take 2 into G minus 1 moves, right? To travel the entire tree. And G nodes means G minus 1 edges. Each edge travel 2 times 2 into G minus 1. No matter what is the structure of the tree, the time will be same. That is the lovely beauty of the structure of the tree. S2, guys, you will do the same thing. Same thing and same thing here. Let's say it is S, so it will be 2 into S minus 1. Add this and the answer while breaking a particular edge has been calculated. Now try breaking all the edges efficiently and in O of n square the problem is solved. Even O of n square is so nice. O of n is just brilliant. It looks like a highway. The hint for O of n is that there is only a single path possible from node 1 to node n because it's a tree. And only the edges on those paths need to be broken, not all the edges. And that makes the problem even efficient to optimize for O of n. Now let's go to the coding part, guys, for this 4 crore software engineering quant SWE problem. Each person watching this video, I can guarantee that you can also crack such high paying packages. Just increase your focus. You can see the C++ code, like, you know, storing everything, the graph and all, taking the 1 and 0 values, doing the, you know, special BFS tree pruning algorithm from node. Like we will create 2 graphs. So you can see, guys, we have to remove the edge, right? So let's say I'm trying to remove the edge U1, V1. So U1, V1 edge I'm removing for this iteration. So you can see G of U1 removed this edge, right? Because it is an undirected tree I've created, right? Once the edge is removed, I will do this tree pruning algorithm on from node 1 for the first subtree and the second subtree. They are not connected. The tree pruning algorithm here. Once that the tree pruning algorithm is done, like this is not the direct tree pruning algorithm. First we try to calculate which are the leaves in both the trees. Once I got the leaf in both the trees, the degree of all the nodes, then I'm doing the tree pruning algorithm of the first subtree, tree pruning algorithm of the second subtree. And now, guys, I know what were the initial number of nodes in that subtree and finally after deletion how much. So that's helping me with the answer. This flag 0 is a very important thing, guys. I leave it up to you. Why have I written this thing? Because we are trying to break each and every edge. Sometime it can happen. Be careful with the test case. Let's say this is node 1 and this is node n. Okay. Let's say you try to break this edge. If you break this edge, the node 1 and node n is coming in the same subtree only, and in the second subtree there is not node 1, node n. You have to break only those edges which divide the subtree 1 in another part and divide the subtree with node n in another part. So if this is not happening, like if you are able to visit from node 1 to node n, even after breaking the edge, it means both are coming in the same subtree. That's why flag equal to 0 case is there. So if flag is 0, only then you calculate these answers. If flag is 1, it means that node 1, node n are coming in the same subtree, so you cannot apply that algorithm. Before trying to break another edge, we put back the U1, V1 edge. Wow, what a lovely problem, Ram Ram. The Ram Ram Gyan is also given, so make sure you go through it. Okay, now let me save the recording. This document will be available to you. I love you all. Do the hard work, especially when you don't feel like it. Ram Ram. Mwah.